formula review session for CFA Level 2 Portfolio Management. So there's roughly a total list of 37 formulas which we'll be dividing into two parts. So let's start with the first one. First one is portfolio expected return. So what we know is if you have two portfolios, if there are two assets, both of them have expected return, let's say 10% and 15%. Their weights as 60% and 40%. Then expected return of the portfolio is nothing but weighted average, which in this case would be 6 plus 6, which would be 12%. Then portfolio standard deviation of two assets. So standard deviation of a portfolio would be made of weight 1 standard deviation 1 square, weight 2 standard deviation 2 square, plus 2 into weight 1 weight 2 standard deviation 1 standard deviation 2 correlation coefficient. Now the idea is that if correlation coefficient is equal to 1, then the whole term is nothing but a plus b square, and therefore if correlation coefficient is equal to 1, the portfolio standard deviation would simply be weight 1 into standard deviation 1 weight 2 into standard deviation 2. If correlation coefficient is equal to -1, then this would be a minus b whole square. Therefore portfolio standard deviation will simply be weight 1 standard deviation 1 minus weight 2 standard deviation 2. And if correlation coefficient is equal to 0, then the whole last term will become 0, and therefore portfolio standard deviation would be equal to weight 1 standard deviation 1 square weight 2 standard deviation 2 square, which is not same as this value. Okay, these are different values. The lowest correlation coefficient is, the lowest portfolio standard deviation will be achieved when correlation is -1, highest portfolio standard deviation when correlation is +1, and 0 would be between these two values. Then portfolio standard deviation 3 assets, formula would be weight 1 standard deviation 1 square plus weight 2 standard deviation 2 square plus weight 3 standard deviation 3 square plus weight 1 standard deviation 1 weight 2 standard deviation 2 into correlation coefficient, this should be 2, plus 2 into weight 2 standard deviation 2 weight 3 standard deviation 3 correlation coefficient, this would be between 1 and 2, this would be between 2 and 3, plus 2 into weight 1 standard deviation 1 weight 3 standard deviation 3 into correlation coefficient between 1 and 3. The whole term should be under root. Moving further, sample covariance. Covariance standard formula is summation of x minus x bar y minus y bar, but since it is sample, your denominator would be n minus 1. What we want to remember is that unit of covariance is always percentage square or unit square, which is meaningless. If you have two data set A and B, C and D, if A and B has a covariance of 10 and C and D has a covariance of 12, we cannot say that C and D has a stronger relationship than A and B. We just look at the absolute values of covariance. We do not look at, we just look at the sign of covariance. We do not look at the absolute value. So two things to remember with covariance. One is the absolute value does not indicate anything. We just look at the sign, which is positive means positive covariance and negative means negative relationship between the variables. Then covariance using the probability data. So let's say you've been given data like this: x is equal to 10, x is equal to 12, x is equal to 15, y is equal to 7, y is equal to 9, y is equal to 20, and you've been given weights, so 0.5, 0.3, 0.2. Then with this data, the formula that we would be applying is summation of probability x minus x bar y minus y bar. We would not be dividing this value with n because we have already multiplied with p, and this x bar and y bar will not be simple arithmetic averages, those would be weighted averages. Are we good to go ahead? Then the formula for correlation. Correlation is nothing but standardized covariance. Therefore, covariance between A and B divided by standard deviation of A and standard deviation of B. And correlation is bounded by -1 and +1. Next formula is variance of equally weighted portfolio. Okay, using variance and covariance as the data set. So variance of equally weighted portfolio would be equal to 1 divided by n into average variances plus n minus 1 divided by n into average covariances of those portfolios. Okay, now the trick to remember here is that as n increases, the first term will get closer to 0, whereas this value will get closer to 1, and therefore this value will get closer to covariance. And the economic interpretation of this is that as the n increases in an equally weighted portfolio, the individual variances become less significant and the importance of average covariance increases. Next formula would be variance of equally weighted portfolio, but this time using the correlation. So now variance of equally weighted portfolio would be equal to average variance of all those individual portfolios divided by 1 minus r divided by n multiplied with r. Okay, so variance of equally weighted portfolio would be equal to an arithmetic average of all the variances multiplied with 1 minus r divided by n into r. Are we good to go ahead? Then Sharpe ratio. This is straightforward. Return on the portfolio minus risk-free rate divided by standard deviation of the portfolio. At times, Sharpe ratio is also called as risk-reward ratio. So both of the ratios would mean the same thing. Then capital allocation line. Return on portfolio P is equal to risk-free rate of return multiplied with Sharpe ratio of asset A into standard deviation of portfolio P. Next, CML, 4 types of calculations. We'll spend some time on this particular formula. So let us say that we have been given, so standard formula for CML is expected return on particular portfolio P is equal to RFR plus Sharpe ratio of market multiplied with standard deviation of portfolio P. This is standard formula, and there are generally 4 types of questions that we can expect on this. So let us say the data given in the question is like this, that return on market is 20%, risk-free rate of return is 10%, standard deviation of market is 5%. Now first question, that a client expects to take risk of, so standard deviation of the portfolio is given as, let us say 6%. What is the rate of return that client should expect to earn? Now one way is we can simply substitute this data in the equation. We can put RFR Sharpe ratio, but easier way of dealing with this question is first you calculate what is the Sharpe ratio of this particular market portfolio. So 20 minus 10 divided by 5, Sharpe ratio of this portfolio is 2. And what is the interpretation of the Sharpe ratio? So interpretation of this Sharpe ratio is 1 standard deviation will result in 2 excess return. So over and above excess return on RFR would be 2. So if you're taking standard deviation of 6, that means excess return would be 12 plus RFR of 10. That means we are looking at total returns of 22%. Or another way of thinking is, at a risk of 5 we are earning returns of 20. Therefore at the risk of 6 we should earn incremental return of 2, so it should be 22. Next type of question on this would be, if a client wants to earn expected return, let us say of 24%, then what should be the risk of the portfolio? So again, how would you approach this? You would say that compared to 20, client wants to earn extra 4%. Since one risk will result into 2 standard deviation, therefore client would be required to take extra risk of 2, which means standard deviation here should be 7%. Because at risk of 5, there was a return of 20. So additional 4 will come at additional 2 risk, therefore standard deviation would be 7%. Then third type of question that can be asked, that if the client is willing to take risk of, let us say, 4 standard deviation, then what should be the weight in risky portfolio? What should be the weight in risky portfolio, and what should be the weight in RFR? Now the easiest way to deal with this is to remember this formula, that standard deviation of your portfolio would be equal to standard deviation into market multiplied with weight in the market. Okay, the idea with this is that by definition RFR has a standard deviation of 0 and RFR has correlation with other variables as 0. So the formula, which is weight 1 standard deviation square, the second and third term will become 0, and therefore your portfolio will just come out to be this variable. So if the client is willing to take risk of 4, the weight in the risky assets simply would be calculated as 4 divided by 5, which would be 80%, and therefore weight in RFR will become 20%. Then if client expects to earn a return, let us say of 16%, then we would be asked to calculate what are the weights. So the way to deal with this is, if client expects to earn a return of 16%, that means client is willing to take standard deviation risk of 3%. Since he is willing to accept return which is 4% lesser, that means 2 notches of risk downwards. And if this is 3%, that means weight in the risky asset has to be 60% and weight in the RFR has to be 40%. So these are the 4 possible types of questions on CML. Are we good to go ahead? Then SML. Equation of SML is nothing but standard capital asset pricing formula. So risk-free rate of return plus return on market minus RFR multiplied with beta. Question 13 or formula 13, the formula for beta. Formula for beta would be covariance between stock X and market divided by variance of market. Now we can extend this formula further. Now we can say that covariance of X and M is same as correlation between two variables into standard deviation of X into standard deviation of M divided by variance of M, which is equal to standard deviation of M into standard deviation of M. So you can eliminate the 2 standard deviations, and the next formula for beta would be correlation between X and M multiplied with standard deviation of X in the numerator, which means standard deviation of asset in the numerator, and standard deviation of market in the denominator. Next formula. Now this is an interesting one. Decision to include a new asset to a portfolio using correlation of Sharpe ratios. So how do we deal with this? Let us say that current Sharpe ratio of your portfolio is given as 0.4. Now you are considering adding a new asset. Now the new asset has a Sharpe ratio, let us say of 0.6, and it has a correlation with the existing asset of 0.2. And then the question will ask, should the new asset be added to the existing portfolio? And the decision making factor here is that we will add a new asset to the portfolio add new asset to the portfolio if correlation of existing asset if Sharpe ratio of existing asset, so let me call this as Sharpe ratio of current asset, multiplied with correlation with the new asset is less than Sharpe ratio of new asset. Okay, so in this particular example, the Sharpe ratio of current asset is given to us as 0.4 multiplied with the correlation of the existing correlation with the new asset is given as 0.2. This we have to compare with the correlation of new Sharpe ratio of new asset, which is given as 0.6. So this value will come out to be 0.08, and since 0.6 is greater than 0.08, the decision in this case would be yes, that when the new asset is added to the existing portfolio, it will result into better diversification benefits. Okay, so the formula that we would want to remember is Sharpe ratio of the current asset multiplied with the correlation with the new asset, and this we are going to compare with Sharpe ratio of the new asset. Next one, market model expected return. This is a straightforward formula. Expected return on particular portfolio P is equal to alpha plus beta into expected return on market plus a random error term. So straightforward regression formula. Then market model of variance. Formula for variance in market model would be variance of a particular security, let's call this as P, is equal to beta square into variance of market plus variance of the stock specific risk, which is being referred to as the error in this case. So variance of portfolio P is equal to beta of, or variance of asset P, this should be square. Variance of asset P would be equal to beta square plus variance of market plus variance which is stock specific. So this portion is called as a systematic risk. This portion is called as the unsystematic or stock specific risk, and this variance would be considered as the total risk. Okay, so easier trick to remember in this case is that all the values are squared. So squared variance is equal to beta square plus variance of market square plus the variance of stock specific risk. Moving forward to the next formula, market model covariance. Covariance of particular security with the market would be calculated as beta of the first asset multiplied with the beta of second asset multiplied with the variance of market. So beta of the first asset into beta of the second asset multiplied with the variance of the market. Then the next formula, instead of beta, this formula should be for correlation. Covariance between security X and Y divided by standard deviation of security X into standard deviation of security Y. Then the formula for covariance would be beta of first security X multiplied with beta of second security Y multiplied with the variance divided by standard deviation is nothing but under root variance, which would be calculated as beta square into standard variance of market plus variance of that particular security multiplied with again the standard deviation of second value, which would be beta square into variance of market plus variance of that particular security. Right, so if we have market model data and if the question is asking us to calculate correlation, then simply using the first two formulas you can derive the last formula. Are we good to go ahead? Then reduction in number of estimates using the market model. Now generally we know that if there are n assets, then the number of correlations that would be calculated would be n into n minus 1 divided by 2. But by using market model, you can significantly reduce the number of estimates. The number of estimates required in market model would be 3n plus 2. So we've already seen the 19th formula. Let's look at 28th, adjusted beta. So again, I don't think you require to remember this particular regression equation, but the most standard regression used for adjusted beta is 1/3 divided by 2/3 into original calculated beta. Okay, so this is a standard Bloom model which is calculated based on the concept of mean reversion. Then 21, macroeconomic factor model. So expected return on particular asset is equal to, so let me call this as expected return on asset A is equal to, again expected return, so let me just call this as RA, plus the factor sensitivity, so let's call this as beta, into the premium, plus beta into the premium, right? Whatever number of macroeconomic factors that you've estimated. Now important thing to remember here is that this premium, or in fact instead of calling premium, let's call these as shocks, that these variables by default are considered to be 0. Okay, which means the shock in macroeconomic factor by default is considered to be 0. So in equilibrium, this RA, which is the intercept, is nothing but the expected return. But if there are shocks in the macroeconomic factors, which means if the GDP turns out to be more or less, then these values would be positive or negative, and that will change your expected return in this particular model. Then arbitrage pricing theory model. So expected return on particular asset is equal to RFR plus beta into risk premium. Okay, so this beta is the factor sensitivity and this is the factor risk premium. Again beta into risk premium plus an error term. Now the question is how these two models are integrated with each other, the macroeconomic factor model and arbitrage pricing theory model. So let me plot both of these equations parallelly. So first let us plot the arbitrage pricing theory model, which says that return on asset A is equal to RFR plus factor sensitivity into risk premium, so on and so forth, plus an expected random error term. Now in case of macroeconomic factor model, we will say expected return on that particular asset A is equal to, again expected return plus the sensitivity to macroeconomic variable into the shock. Okay, and so whatever the number of factors you've chosen. Now the idea is that expected return that we have calculated using arbitrage pricing theory model is going to be your intercept in the macroeconomic theory model. Okay, so which means in equilibrium, based on the risk sensitivities that we identified in the APT model, let's say you're expected to earn a return of 20%. So in macroeconomic model, your intercept would be 20%, and if there are no shocks to the macroeconomic variables, you would earn 20%. But if GDP turns out to be more or interest rate turns out to be lesser, then your actual return earned are going to be a different estimate. Should we go ahead?